This video reviews the notes on speed for the unit Newton's laws. One of the things that we must do when we are considering speed and calculating speed is we must look at the units in which speed is being measured. Oftentimes, speed is being measured in either meters per second or kilometers per hour. Oftentimes, it is required for the person who is calculating speed to convert those into usable units. This exercise looks at how we do that, converting units to usable units. Note that we have two calculations here for converting both distance and time. 1 kilometer is equal to 1,000 meters. That is the same distance, it's just different units. Also, there are 3,600 seconds in 1 hour, conversion for time. One of the easiest ways to solve one of these problems is to create a factor label method, which is similar to using a proportion in math class. I will demonstrate how to use the factor label method. First, write down the units that you are using. We have 1/1600th of a kilometer, and we need to move that to a usable unit of meters. We know that there are 1,000 meters in 1 kilometer. By using the factor label method, we can put 1 kilometer opposite in a fraction and multiply it. So here we got 1/1600th of the kilometer times 1,000 meters divided by 1 kilometer. When we type that into the calculator, 1/1600ths times 1,000, we see that the answer is 160. We record that as 160 meters. Let's set up the next factor label. We have a half hour. We want to know how many seconds that would be. So we multiply that by our number of seconds. So it's 3,600 by 1 hour. So basically saying half of 3,600. As we saw in the calculator, our answer is 1,800 seconds. Pause this video now and see if you can do C and D on your own. The correct answer for C would be 1.9 kilometers, because I'd be taking 1,900 meters divided by 1,000. And the correct answer for D would be 42 hundredths of an hour, which would be taking 1,515 seconds dividing it by 3,600 seconds. Now on the opposite side for E through H, it says that those are difficult. It's because you have to do two conversions at one time, converting meters per second to kilometers per hour. The factor label method helps to make sure that you get the right units at the end. For instance, we're starting with 8.6 meters per second. Our goal is to get to kilometers per hour. So what we must do is change those units to the proper ones. One of the first things I want to do is change that meters to kilometers. I know that there is 1 kilometer, and in that 1 kilometer there would be 1,000 meters. I put it like this because as in doing a proportion, or in the factor labeling method, I would cancel out the meters to get me kilometers in that setup. I then want to get hours from seconds. So I'm going to put hours in our denominator here. 1 hour is equal to 3,600 seconds. When I plug that into the calculator, 8.6 divided by 1,000 times 3,600. I get an answer of 30.96. To check that we are getting the right answer, we go through and cancel out all the units. We start out meters per second, but I divided by meters here, so meters is canceled out, leaving me with kilometers. I start with seconds and meters per second, but then I multiply it by seconds to get hours in the denominator. So I end up with the units kilometers per hour. That's what makes factor labeling such a great tool. Let's look at F. We want to convert 88 kilometers per hour, and we want to get to meters per second. So immediately I want to go and try and convert kilometers to meters. And I know that there's 1,000 meters in a kilometer. And I also need to convert hours to seconds. I know that 1 hour is 3,600 seconds. Note that I'm putting, because hours is in the denominator here, in the numerator here, to get the values and the units to cancel out when I go do the factor label method. When I put that through the calculator, 88 kilometers times 1,000 meters gets me 88,000 meters, and I want to divide by the total number of seconds. The answer I get is 24.444 repeating, or 24.44 would be fine. Try G and H on your own. Pause this recording. The answer to G was 3,672 kilometers per hour. And it seems like it's a lot because moving 1,020 meters per second is a lot. That's a fast moving object. And for H, 20 kilometers per hour to meters per second should be 5.56 meters per second. And that's how we use the factor label method to determine the units for speed.